if you talk about fine-tuning in physics, it is usually being used as an observation of a specific system, and within that system, the question is that a hint for an explanation?
When you compare any two theories, one theory can't taunt another theory with a fact that neither of them explains.
You think that the underlying mind or the designer, whatever is responsible, was constrained at all in designing that universe?
In 1998, we discovered the cosmological constant. That cemented in one of the best cases of fine-tuning.
Apparently, if we take that seriously, there has been a designer, a mind that designed the universe, but then it's not powerful enough to have us figure out morals for ourselves. It has to come back and intervene at that point. Is that not something that concerns you?
Then we're talking moral philosophy, and I'm not a moral philosopher. You're not a moral philosopher. I'm not sure. You're a philosopher of mind? Yeah. I mean, is there anyone in the house?
Hello and welcome to the Unbelievable podcast, the show where Christians and non-Christians come together to debate and discuss the topics that matter to all of us. I am one of your regular hosts, Andy Kind, and today we've got a great debate recorded in front of a live audience at the University of Durham in England between two physicists looking at whether the universe is fine-tuned for life. All the way from Sydney, Australia, we've got Dr. Luke Barnes, who's a senior lecturer at Western Sydney University. His research focuses on the cosmic evolution of matter, and he has published on the fine-tuning of physics for life that we're talking about today. Then for the opposition, we have Martin Bauer, who's an associate professor at the University of Durham. Bauer's research focuses on dark matter and Higgs physics, to name but two. This event is funded by the Panpsychism and Panentheism 3-year project that Dr. Philip Goff and Andrew Buchareth run at Durham University, which is currently funded by the John Templeton Foundation. Professor Philip Goff, no stranger to Unbelievable, of course, is moderating the debate and begins by asking Dr. Luke Barnes why, in his opinion, physics points to God.
Well, thanks for coming out. Let me start my timer. Yes, perhaps in some sense, that might be the best sort of thing I'm going to aim for today. Here's, first of all, what are we talking about when we talk about God? And then 3 reasons at least to take this seriously. And I think, as was said, the point is that you go out after this and you have better conversations, right? Get some mates. Don't go to that pub. Go to the good pub and have a chat. Have a better chat. So here we go. Here's 2 sort of classical deep questions of existence. Suppose we could dig down to reality's core and try to work out what's going on down there. What would we find? Well, here's the first question. Is it down there at ultimate reality, is it necessary or is it contingent? These are 2 really, really useful philosophical terms. Contingent roughly means that it could have been different. So, for example, my name is Luke, but my parents nearly called me Andrew, so that's a contingent fact. It could have easily been different. By contrast, if you think about a fact like 2 + 2 = 4, it seems to be true in some sort of stronger way. It's necessarily true. It had to be true. It doesn't depend on circumstances. So, applying this distinction down at the bottom, will ultimate reality turn out to be something that had to be the way it is, necessary, or something that just could have been different? There's question number 1. The second question is, what kind of thing is down there at the bottom of reality? So here's 3, not all the options, but 3 to be getting on with in the pub later on. Perhaps it's matter at the bottom. Perhaps down at the bottom there's just physical, concrete, mechanical stuff. Or, option 2, perhaps it's mathematics at the bottom, a la Pythagoras, Plato, and Max Tegmark. There's a trio. Maybe mathematical structures and physical structures are really the same thing. So everything at bottom is mathematical. Or, third option, maybe it's mind at the bottom. Maybe the ultimate stuff of reality is consciousness. Thoughts, experiences, reasons, decisions, that sort of thing. Now, that's not an exhaustive list, but between the 2 questions, necessary, contingent, matter, mathematics, mind, there's 6 ways to put those options together, and I'll leave all but 2 as an exercise for the reader. Naturalism is the idea that you take contingent plus matter at the bottom. So there just is the natural material world. It could have been different. It could have not existed at all, but it just is the way it is. And that's all there is to be said. So to quote cosmologist Sean Carroll, there's a chain of explanations concerning things that happen in the universe, which ultimately reaches the fundamental laws of nature and stops. Right? You get what you get and you don't get upset. By contrast, theism, the idea that there's a God, chooses differently. It chooses necessary plus mind. There is a necessary mind that we call God. Just as 2 + 2 = 4 has a different mode of truth to my name is Luke, so God has a different mode of existence. God must exist in some sense. So here's the crucial point before we get into this. To take these ideas seriously, we have to remember that we're renovating all the way to the foundations. To take naturalism seriously, you have to take the fact that things are contingent seriously. You have to let go of the idea that all questions have answers and that everything that exists has an explanation of its existence. To take theism seriously, you can't just take the natural universe and try to install a gratuitous sky fairy into the attic. That won't work. We're talking about the foundations, not the furniture. So, why take God seriously from physics? Here's 3 reasons. The first one is historically the makers of the scientific revolution put mind at the bottom. This isn't so much an argument, but it should counter any sort of suspicion that, science is great and it does science and science is happening and wonderful science, and then some lunatic comes along and tries to superglue their God to the outside of the universe. That's not how science started. Science is the search for rationality and order behind the appearance of the natural world. The reason people tried to do that is because to try to look for a rational order behind nature was because they believed there was a rational mind behind nature. Mind at the bottom as a foundation fits neatly with matter that obeys rational laws. Now, as I said, doesn't prove God, but just let's remember historically who got science started and then who turned up, after all the heavy lifting was done. So 2, what the book's about, what a lot of my research is about. This fine-tuning of the universe for life. So consider our universe right back near the beginning, 1/1,000,000th of a second old. It's, at that time, 10 trillion degrees. A number that sounds like I just made it up. But that is, in fact, the correct number, as far as we know. The universe is almost perfectly smooth. It contains simple stuff, building blocks, quarks, electrons, particles of light, throw in some antiparticles, some neutrinos, if you like, dark matter, some dark energy. There's nothing particularly complex going on. It's too hot even for protons and neutrons, let alone anything as complex as an atom or some molecules. And it's also too smooth for any sort of cosmic structure, stars, galaxies, anything like that. But the die has been cast. A hand has been dealt to the universe. We can think of these fundamental properties, these constants, as cards that the universe is holding. They encode what the stuff of the universe would do in various environments. Over the next 13.8 billion years, these cards will be played at various times and in various combinations. For example, there are cards that say what quarks and electrons will do at room temperature. Now, that's all really rather hypothetical when the temperature is 10 trillion degrees, but the properties are already there. The cards have been dealt relevant to physical conditions that haven't even happened yet. Now, forget for a moment that we know how this story ends. Let's not take our universe for granted, and let's reshuffle the cards. Let's redeal and look at what a typical set of cards will actually do as the universe plays out. This is what theoretical physicists have done in the literature for about 5 decades now. The typical case doesn't look a lot like this universe. Quarks fail to produce protons and neutrons or any kind of structure, and the entire periodic table is erased. Electrons can be captured by nuclei, making even atoms impossible. Matter could fail to cool and collapse into galaxies, leaving us with no cosmic structure. Maybe gas clouds fail to ignite as stars. Gas clouds, or on the other hand, could collapse too efficiently, making a universe full of black holes. The heavy elements that are created inside stars could very easily have just lived and died in there, never getting out into the wider universe to create planets. And if the dark energy card is played too early, everything gets really far away from everything else really quickly, and nothing ever touches anything. Or, if the dark energy card is negative, the universe lasts for a millionth of a second before it recollapses, never cooling below 10 trillion degrees. That is the typical universe. Deal the cards at random, and that's what you get. You get what you get, and there's no one around to be upset. Now, having watched the universe's shuffled hands lose again and again and again, let's rewind and look at what our hand does. A millionth of a second after the Big Bang, let's watch the cards play out. Even this early, dark matter is lumpy enough to begin collapsing into halos, which will provide the skeleton for later structure. The universe cools. Structure continues to form. Ordinary matter is drawn into dark matter halos by gravity. Thanks to electromagnetism, it can collapse even further. The universe plays its stellar physics card, and stars light up. They are both a stable energy source and the source of heavier elements, because small stars are stable and big stars blow up. The heavy elements distributed by big stars collect in galaxies and form planets. On these planets, something unseen before in the universe turns up: atoms. They bind, they form molecules, they form solids and liquids. That's never happened before. Molecules interact, powered by a remarkable coincidence that the typical amount of energy you get from a particle of light from a star happens to be, thanks to a coincidence of constants, the typical energy of a chemical bond. So photosynthesis is written there in the cards. These chemicals aren't just paint-by-numbers affairs. From 3 building blocks, up quarks, down quarks, and electrons, the number of known chemical compounds in the PubChem database on Tuesday was 119,083,511. You can write code with these molecules, and our universe does: DNA, amino acids, proteins, cells, life, and intelligence. All there in the cards. Our universe was holding 4 aces before the game started, when it didn't even know what the game was. We know what this looks like. It's the most familiar thing in the world. Thankfully, some of the first physicists who worked this out were honest enough to blurt out the answer. In 1971, Freeman Dyson said, "As we look out into the universe and identify the many accidents of physics and astronomy that have worked together for our benefit, it almost seems as if the universe must have in some sense known that we were coming." That is a signature of minds. Foresight. A mind can think about possibilities before deciding what to do. You know this because you are a mind, which brings me to my third point, which I'm going to have to squeeze in rather quickly. Having laid the foundations, whatever you choose, matter, mind, maths, you have to ask how well the foundation supports everything else. So, if you put matter at the bottom, can it support minds above it? If you put matter at the bottom, I'm going to specifically focus here on consciousness. We have first-person subjective experiences. Consciousness is what comes back to you when you wake up. It's what's missing when you're sleepwalking, and it could remain even if your awareness of the outside world were taken away. Is consciousness the kind of thing that can arise in a matter at the bottom universe, or does it present a hard problem? It's actually called the hard problem. That's what this is known in philosophy of mind. I feel that I am just rampaging all over at the moment. Here's from a physics point of view what's going on here. I'm a simulator. I write code to simulate physical systems. One of my favorite supercomputers is somewhere around here. Cosma. I'm going to take my laptop over to meet it later on. It's going to be adorable, right? When I look at a simulation of the universe, I'm presented with a list of things that a natural explanation can appeal to. Particles, positions, velocities, mass, charge, spin, maybe some fields, some space-time, physical laws. From these, I'm allowed to talk about higher level up concepts, like, for example, galaxies, which is what the simulations I'm looking at actually try to make. How do I find a galaxy in a simulation? It's crucial that whatever criterion I have has to boil down to those basic quantities. Right? For example, we asked, are particles gravitationally bound to each other? What I can't do is propose a law that doesn't, in principle, boil down. I can't say galaxies just have an extra bright pink glow just because they're galaxies. The laws of nature don't know about galaxies. We talk about galaxies as a convenience. They're a useful way to carve up the universe. But if we wanted to, we could talk about the way the structure in our universe is going without invoking that concept. It would be inelegant, but it should be possible. So here's the problem. Imagine I look at one of these simulations and say, you know what? That stuff there, I think it's going to wake up. I think it's going to have experiences, thoughts, and feelings. It'll have a subjective inner life. Now, already that's a little bit weird, but here's the real problem. If that's just an emergent phenomena, which is what it has to be if matter's at the bottom, then there should be a way of talking about the universe which completely avoids that. But we know that consciousness exists. We know that before anything else. It's the first thing we know. It's the one thing about reality that can't possibly be an illusion. So, this isn't about complexity. Add whatever you like to the simulation. Have your galaxy process information and have layers of memory or parallel processing, whatever you like. The fact that for a physical idea, I can erase it by talking about a deeper level can't be the case with consciousness. So it can't be a physical thing. Put mind at the bottom and matter will fall into place. Put matter at the bottom and you'll lose your mind. Thank you.
Well, I'll invite Martin now to give his perspective on these thorny issues.
Right. So I also want to thank Philip for the invitation. It's great to be here. Very interesting to me. I haven't been involved in debates like this before. He's definitely ambitious. So the first exchange that we had was a question of whether we can debate fine-tuning in physics. And 3 emails in, he asked whether we can settle whether God exists in the same session. So certainly high goals here. I'm a physicist. I'm not a philosopher. I haven't spent a long time thinking about philosophical questions. So I will also focus on whether physics has anything to say about these philosophical questions. And I will mostly focus about fine-tuning. The question of whether the constants or whether this universe has been set up or is precisely set such that we can exist, fine-tuning for life. I will bring forth 2 objections here on which I want to focus. And the first is based on the fact that if you talk about fine-tuning in physics, because there's a lot of confusion about how these terms are actually being used, it is usually being used as an observation of a specific system, and within that system, the question is that a hint for an explanation? Is there something deeper that explains this structure, which seems to be not something that you would generically expect in such a system? I can give you 2 examples, and I hope they're not too technical. The first I want to bring on is what's called Fraunhofer lines. So after Newton had figured out that you can use a prism to look at white light and it splits it in all its colors, people start to do that everywhere to analyze what kind of spectrum you get. And they looked at sunlight, and when they did that in the early 19th century, was actually, even though it's named after Fraunhofer, it was a German, it was a Brit who did discover that first. Fraunhofer lines are little black lines in the spectrum that are blotted out, that you don't get any light there. You get all the spectrum of red and green, and then there are these little lines in between. And when they was discovered, there was no explanation for it at all. There was no hope of an explanation. If you took these things and you looked at the whole spectrum of wavelength, you would wonder, why do all these lines show up at a very similar wavelength. So Fraunhofer eventually cataloged 570 different lines, and they are not too far apart. Well, if you plot the whole spectrum of electromagnetic radiation, you would all find them in a similar area of wavelength. And there was no explanation. Then time went on and people started to have theories about that. And the prevailing theory that came up in the 1860s, which eventually was confirmed, is that the sun is made of similar stuff as everything else. And there are atoms in the corona of the sun. And when the light tries to get off from the sun, these atoms absorb at a specific wavelength. And that's why that specific light doesn't make it to Earth. So we don't see it. Well, that still presumes that for some reason, all these atoms, all these different systems that are appearing there, blot out light at specific wavelengths that are all grouped very narrowly. You could call it a fine-tuning problem. Why are they grouped like that? Right? Why wouldn't they be like distributed over the whole spectrum of electromagnetic light that we can observe? And it took even longer to answer that. Like eventually people had models of the atoms that make up matter. And they said, okay, the electron is somewhere around the nucleus and it is only at specific places. And therefore, we only have specific absorption lines, not a continuum of absorption lines, which gave rise to another fine-tuning problem, because who put the electron there? Why is it only in these particular distances from the nucleus if you describe it like a Bohr atom? And the resolution was quantum mechanics, a very deep structure of nature that was only discovered 100 years after the first observation of these Fraunhofer lines. So the question of whether there was a tuning that resulted in these specific observations gave rise to deep understanding, to a structure that is underlying this particular set of theories. You probably wouldn't have arrived there if you would have asked the question of why are these lines there, why other scales like the size of a building or the size of the Earth is completely disparate to those, right? Is there someone who put it that way? Later on, people discovered more subatomic particles in the 50s and 60s, what's called the particle zoo, where a bunch of states were discovered that randomly appeared in accelerators and then decayed away. Pions, kaons, sigma, lambda, baryons, a lot of stuff that isn't necessary for life at all, apparently, but it showed up in these experiments. And eventually it could be explained. It was a hint of quarks and gluons, a more fundamental theory. They all show up at a different mass scale, at a similar mass scale, and the reason for that is not that there's someone tuned them finely away from some other scales, is that there's an underlying mechanism for that. The question of whether the universe is fine-tuned for life is a different question. It is not a question about a specific theory or a specific setup that we can observe and test further. It is at least it shouldn't be. It shouldn't be constrained to that, right? And that brings up the question of who decides what to vary in these situations, right? Or in Luke's example is who deals the cards, who actually decides that it is a card game that we are playing, right? One example that Luke also brings up in his book is the mass difference of quarks, say the down quark and the up quark, or the mass difference between the proton and the neutron, which is absolutely essential for life. If there was any different, even slightly different, early on, protons would decay and atoms wouldn't form. Or the number of protons and neutrons would change, and we wouldn't have the chemical elements, or we wouldn't have the abundance of chemical elements that we observe. So it's often brought forward as a very good example for fine-tuning, because they seem to be exactly put where they need to be to give rise to all the structure that we observe. Well, that is true if the parameter space that you're looking at is the mass of these two particles. Because if I change the electroweak scale, I might as well change the masses, and I would still end up with the chemistry that we have. Who tells me that I can only change these two parameters and not anything else? Why wouldn't a designer or a god constrain themselves to these two particles that are relevant to build nuclei? Why not 5 billion quarks at possible different scales? Why not throw those in, which will make it less of a coincidence that you have 2 or 3 pretty close together? Why would there be a weak force that lets the neutron decay? Why do you have a universe where there is a Big Bang? Why not set it at the precise level that the chemistry is there that you need? Why do you have atoms in the first place? I can imagine a universe with no atoms, completely different laws. Why mathematics? Why not have a universe? So an argument was that 2 + 2 is 4 fundamentally. The version of mathematics that we found is the version of mathematics that we found. You can come up with a completely different system and you can build your universes over there, right? So does this god or this designer or whoever's responsible for the fine-tuning have to work in a fixed framework, and who decides what fixes that framework, right? Imagine we find Like Luke and I are out and try to find a place where we can play billiard or snooker or something. So we need a flat table, and we find a table and there's 4 legs. And then you could remark, well, this is really fantastic. We can use this table here. It's perfectly flat. It's perfectly even. We can actually use this for the game that we want to play. We can play such a nice complex game on that table. And then Luke could remark that seems particularly fine-tuned. It has 4 legs. The angle of the wood is exactly right. The length is exactly right. If anything of these things would be slightly different, we wouldn't have a table with a flat surface. But, well, you have put up some rules here that you take for granted before you make that argument. Because if you change the angle, you can also change the length and you end up with a flat surface. You can take a leg away and redistribute the 3 legs. I can make that stable too, right? And who says that we have to live in 2 dimensions, or the 3 plus 1 dimensions that we have here? If you put that table in 2 dimensions, if you draw it on a piece of paper, you can make it stable with 2 legs. So if you look at all the possibilities, if you don't constrain yourself to a specific theory where these questions typically come from in physics, then there's absolutely no reason to assume that space of parameters is even finite. It has infinite dimension. I could come up with anything, really. So my objection would be that if you have an infinite dimensional parameter space, any question you ask would guide you to a small subspace, actually an infinitely small subspace. You don't have to ask whether it's the possibility of life or stars or any structure. You could ask any question. If you have an infinitely dimensional space, you automatically will come up with an answer that just points you to a tiny subspace there. So I think fine-tuning arguments like that one has to be really careful about, because they basically are an illusion because we limit the parameters that you're allowed to change, right? As soon as you do this, apparently everything is fine-tuned for that particular outcome, but that first initial step is already problematic. That would be my first objection. I have a second one, which I think is even deeper than the first, and that is when you ask the question, is the universe fine-tuned for life? Don't you already bring some bias into that question? Why ask, is it fine-tuned for life in the first place? And I have a suspicion of why that is the question that is interesting to us. And that is because that category of life contains us. We, as humans, have a deep-sitting need, apparently, to feel special about our place in the universe. This is something that you can trace through the history of humankind. You can trace it through the history of science, and has a really, really bad track record. Whenever we argue from that point of view, typically, I don't want to say it is 100% certainty that that's the outcome, but whenever we use this as a guiding principle, it has led to confusion and has hindered progress in science. So one point I want to make is that to argue the universe is made for life, to say it knew this outcome in the very early time, like a second after it emerged, all the laws were there, we knew that life would form when the universe cools down to a certain point, is really just taking a snapshot, and it's taking a really early snapshot. Because if we take these laws for granted, we know how the universe will continue to evolve. In the not too far distant future, we will collide with the Andromeda galaxy. At some point, stars will cease to form. Our planets, like Earth, the sun will explode before that, but in trillions of years' time, all the planets everywhere in the universe will be circled and crash into their home star. These stars will burn out all their gas. They will eventually collapse into black holes, and those will evaporate away, the heat death of the universe. It's a very bleak and depressing outlook. But my point is that we still are basically a fraction of time after the Big Bang, as opposed to this gigantic time frame that I just laid out. Because when this will happen, if we extrapolate further, it's at least 10 to the 100 years from now. So this is the time in which life is possible in this universe is as a fraction of this extrapolation, less than a nanosecond compared to the time, the age of the universe currently. If this universe was made for life, it was made for life to emerge at a specific time for a very, very short amount of time and then decay away. So why ask the question, is it fine-tuned for life? Why not ask, is it fine-tuned for supernovas to appear, which are complex, beautiful mechanisms? Or why is it not fine-tuned for spectacular decays of the top quark in the very, very early, even before, like what Luke mentioned, like that's a fraction of the Big Bang that we can't even imagine, really, where top quarks were about and were just decay in a fraction of a second. Why wasn't that the purpose of the universe? Why would we put it front and center that we ask about the emergence of life other than our need for having a special place in that universe. We can just go through the list, and this is certainly it's incomplete. Galilei is the most famous example, who proposed heliocentrism, that the Earth is not the center of the solar system, and he was sentenced to house arrest for that. You cannot say, okay, this was the evil Catholic Church, nobody else would do something like that. But Darwin was ridiculed publicly for his idea of evolution, because we humans felt the need to separate us from these lowly life forms that crawled around on Earth. There was not just a church, there was eminent scientists that thought this is complete nonsense. If you look at germ theory, the idea that diseases are the result of tiny living things that enter our organism, when that came up, there was some objections to that. One of the main objections was that for a long time, again, not just the church, but for a long time, the idea that we get sick was related to what we do. If you're a sinner, if you're not morally right, if you do something wrong, you're being punished for getting sick, right? It's not true. We are no better or not different in that sense than any other living form. Any animal gets sick the same way as we get sick. There was no difference there. So again, there was an instance where the idea that we are separate and special was hindering the progress of science. The fact that Earth is much older than human history, right, was something people didn't like to accept. Why would it be? What would happen in these billion years before we were around? But eventually it is true, so we found evidence for that. Again, I want to stress, this is not necessarily a fight between religious worldviews or non-religious worldviews. If you take the Big Bang model was a steady-state universe, Einstein himself modified his equations so that the universe doesn't move. And there were reasons to do that in the first place. We didn't have the direct evidence that we saw the universe expanding at the time he wrote his theory down. But there was also a psychological reason for that. If the universe exploded from a certain initial point, like the Big Bang, and keeps doing that, then the consequences are what I just told you. Our existence in that universe is just a blink of a second. Quantum mechanics, the emergence of quantum mechanics is a fundamental theory. There are still people that are extremely unhappy with the way that works, not because it is not an extremely successful theory, but because it violates our intuition. So my second objection is that this question by itself is inherently biased. And it is in the tradition of biased questions, or of biased assumptions, that always puts us as humans at the center of the universe, of the center of our thinking. And therefore, I don't think it is a particular good question to use to guide our research.
Thank you very much.
Well, we'll leave the debate there for a moment. Let's take a quick break. If you're enjoying the debate, Is the Universe Fine-Tuned for Life, and you're watching on YouTube, please click on the subscribe bell. And if you're listening on Apple Podcasts, please give us a follow, and we'll be back in just a moment.
You would call yourself an atheist?
I would, yes.
I would call myself a Christian humanist.
One of the big themes over the history of what we now think of as science has been questioning the exceptionalism of humankind.
I think the critical thing is what gives something value. Would you say that minds construct meaning or detect meaning?
I have had made from a little piece of my arm something that could reasonably be called a second brain.
I think one of the real challenges that evolution by natural selection puts to Christian belief is the idea that
Welcome back to the second part of today's episode of the Unbelievable Podcast. Later on, we open it up to the audience for a lively Q&A, but for now, here's how the conversation carried on.
Two very interesting perspectives there. So there's the big picture. I'm going to invite Luke to have 10 minutes to respond to what he's heard from his opponent here.
Let me just set a time.
His discussant. Is that a word, discussant?
I don't think so. Okay. Yeah, great. I mean, we can just go to the pub now, right? You're ready to go? Good.
You don't get away that easy.
Let me explain a couple of things. Me, as someone who believes in God and is a scientist, what I'm not trying to do in any of this is cut scientific inquiry short. Now, there's a very important reason why I'm not going to do that. And it's really sort of the first principles of theism. The two rules. One is that there's a God, and the second rule is that you're not God. And so, given that I'm not God, I'm not going to sort of tell God when the universe ends and when God did. Like, we have to go and work that out ourselves. So this is not a let's stop science now and not do anything else, right? So I'm all for going deeper, but it's important to remember what's on both sides here. We believe in roughly the same scientific laws. And if there's a difference, there's just a scientific difference. What's different between us is whether you believe in theism or naturalism. And there's a really important point when you compare any two theories, any two ideas, any hypotheses. One theory can't taunt another theory with a fact that neither of them explains. So if you get sort of the security camera footage of someone robbing a bank, and there's different theories about who it might be, and then it's noticed that the robber was wearing a blue hat, I can't say, your theory doesn't predict that the robber would have a blue hat. If the other person says, no, your theory doesn't predict that either, what are you talking about? So to say that, to raise those questions, why not 5 billion quarks? Why a weak force? Why atoms? Why this mathematics? Why not just top quarks? If naturalism gives you no reason to expect that either, then it's just a dead heat. It's just a stalemate. That's not how we can choose between these if we actually want to know what reality is like at the bottom. So why this question? Do we want to know whether we're special? If that's biased, then yeah. But it's unavoidable because we're us. And we want to know, and it might be true. We don't want to bias against it either. And there's a method here behind fine-tuning. I've got a paper called A Reasonable Little Question, if you want to go and look it up. Here's the idea. If we want to consider what theism would lead us to expect versus what naturalism might lead us to expect, what sort of universe might turn up? Now, if we just ask that in general, that question's too big, as was pointed out. There's too many possibilities. To try and work out whether, which idea about the way reality really is the one that leads us to the right expectations. But there's a way we can carve off a piece of the question. This comes very much in the tradition of physics, just trying to simplify down to a problem I can actually solve. And now is the time to tell you the spherical cow joke. Every physicist knows this one. It's not funny. Okay. A farmer wants to know how he can have his cows produce more milk. He asks an evolutionary biologist who says, what you need to do is find a bunch of cows that don't produce milk and kill them, and then natural selection will make your cows better. That's a joke, right? The chemist sort of cooks up something in a vat and says, just give this to all your cows. And the physicist says, I've solved the problem for a spherical cow in a vacuum with no friction. As I said, not funny. But the idea is, as a physicist, you want a simplified version of it. If you have a big problem you can't solve, try and find a little problem that resembles it and go after that. So here's what we can do. What possible universes could we look at? Well, here's something we could try. Let's take the best laws of physics we have as sort of decided by the data we have, the standard models of particle physics and of cosmology. Anything beyond that is sort of speculation, perhaps useful speculation, but speculation. What can we take from those models, those standard models? What can we vary just to see what's out there in the set of possibilities? Well, we could vary the form of the equations, but that's kind of hard to do, and certainly hard to do systematically. But, thank goodness, helpfully, there are these numbers in there. And they're just numbers. And they vary over a certain range. And we've solved the equations for other sets of numbers, so we could just vary those numbers. There's 31 of them, and only maybe 10 of them actually matter for this. And let's just explore what's there. Let's vary those numbers in our equations, of course, and see what comes out. And see what kind of universe might have just happened on naturalism versus on theism. The reason to think that this is actually a fair scenario is that for the first half of the 20th century, I think most atheists would have told you this is just any old universe. Bertrand Russell saying we're just accidental collocations of atoms. Right? Just any old, you've heard that story 1,000 times. We're just third rock from an average star in the outskirts of an ordinary galaxy, just in the middle of nowhere. This is just any old universe. So if that test had turned out that, hey, just any old constants will do, you'll get bigger chemicals and larger, stars or whatever, but something interesting will happen. That would have been taken as confirmatory of the sort of thing that, say, Bertrand Russell said. We're just any old universe. The fact that it turned out the other way was an enormous shock to the physicists who weren't any sort of theists who actually did the work of varying these numbers. There's a famous quote from Fred Hoyle who said, I've got to get it right now, a common sense interpretation of the facts would suggest that a super intellect has monkeyed with physics. Right? This was a shock. It was if anything, it's biased the other way. If you go looking for something close to a known example of that thing, you're more likely to find it. If you go looking through a set of possibilities, starting with our universe, which we know is life-permitting, you're more likely to find other life-permitting universes. And yet, the test went completely the other way. In this sort of realm, in this test case where we can actually get a handle on this thing, it turns out there is something remarkable about our universe and what it does. I think that this is not the way, so the claim was made, any question leads to a small subspace. That was not what was expected. The opposite was expected. It was expected this would just be any old universe. So there really is something weird going on around here. Finally, let me spend a minute and a half talking about the future of the universe. And I think it's sort of missing the lead here. If you think I should be a bit uncomfortable with a universe that ends out dead, then surely naturalism should be a bit uncomfortable with the fact that almost all possible universes, so far as they know, start dead. They never live. They're dead from the get-go. They're dead from a millionth of a second or earlier, that the whole thing's dead. But it's remarkable. If mind is at the bottom, then a universe that produces minds is something that a mind at the bottom might want to create. But it might have a finite purpose, and we might not be the only thing. So I'm not saying I can predict everything there is to say about the universe, starting from the idea that there's a God. The point is not to say, hey, you predict everything, but comparing the two packages, matter at the bottom, mind at the bottom, what are you led to expect? So the argument is that fine-tuning is a realm in which we can actually sort of make progress on this in a way that seems, reasonable, of biting off a reasonable bit of this question. And so that's, I think, a direction that is useful in trying to decide this sort of question. We haven't talked about consciousness. That's probably fine. I'm happy to let that go through to the keeper if we want to just keep talking about fine-tuning, because that's what I've been doing for an awfully long time, so that's fine with me. Thank you.
Thank you very much. You're both extremely efficient in staying on time. I'm very impressed. So, Martin, what do you think? Do you have anything to say?
I'd probably be more efficient. I think we can almost go straight into the back and forth with questions because it will be more interesting than me repeating some of the arguments. If that's okay with you, Luke.
Yeah.
Sure. So I think this is still my first objection that I don't think has been fully answered. When you say we carve out a question because we look at a specific system and we only vary specific parameters of that system, right? Are you assuming that whoever is responsible, what mind is responsible for the universe, had no other option than stick with that framework?
Oh, so okay.
I'm wondering. I mean, yeah, I can explain a bit more, but
this
I
is
think
your time, so don't.
No,
don't give it up.
Yeah, but I think
of moving straight to open discussion.
I think would. Yeah,
Okay,
I'm fine with that. Yeah,
we could have a bit longer open discussion if that's what you prefer.
Because I think, and you're not uncomfortable with the fact that at any time, like given through the last 100 years, that framework would have changed. So maybe another objection related to that is that what we have as a standard model of particle physics. Although it is extremely successful, we know it's not the final answer. If we had an indication that this theory is final, I think the argument that we now look at maybe just these specific parameters and vary those would be better motivated. But we already know it won't be. We already know there will be more fundamental physics because there are questions that can't possibly be addressed by that framework. So I'm wondering whether you think that the underlying mind or the designer, whatever is responsible, was constrained at all in designing that universe, and that is necessary to come to the conclusion whether it's fine-tuned or not.
Good, great question. Two quick things. First of all, I'm not assuming that God is constrained, but if you're comparing two ideas, we have a chance here to sort of put them in the same arena, right? Because whatever possibilities you can say about, what about 5,000 quarks or all this sort of stuff, are possible on naturalism as well. So if we expand out the sort of possible universes we're looking through that big, we just lose any hope of answering the question. And maybe at the end of this you say, look, okay, we can't answer this question, so we just sort of leave it at that. The thing I'd say to that is that atheists have not been shy for the last 100 years, so I'm not feeling particularly shy in return. So I think I just want to say about the fact that physics is incomplete. I think I just want to take that on board. Let's just take stock of where we are. And if new physics comes along tomorrow, then maybe this argument will go away. Right? And I just want to, I can just own up to that. It's not the case that automatically the progress of physics removes fine-tuning. For example, in 1998, we discovered the cosmological constant. That cemented in one of the best cases of fine-tuning. Physics progressed and fine-tuning got more fine-tuned. So there's not an automatic erasure of fine-tuning as physics goes on, but it's entirely possible. So, Einstein had this dream. Maybe we'll write down laws that don't have any constants in them. At that point, I'd still wonder about the shape of the form of the laws and stuff, but we wouldn't be able to change any constants. This is the best handle we can get on this sort of question. This is a huge metaphysical question, right? Mind or matter at the bottom. And we've been handed an extraordinary way of trying to get a handle on that. And I think we'd be wise to look at it very carefully and not just go, physics isn't finished, and just sort of throw it away.
So imagine we had a universe where the opposite was the case, where you could vary these parameters and you would always get life. Would you say this is an argument against a designer?
What it would be is, so think about this sort of in probability terms, Bayesian. So you've got, here's your ideas about anything.
Do you want to say what Bayesian is?
Not quickly.
Let's get our standard way of thinking about
the doors
evidence.
and I'll do a lecture on it. But so I can explain it like this. So you've got two competing ideas, and before you go and look at the evidence, they have some sort of probability about them. There's just, maybe you think they're roughly equally plausible or whatever. And then along comes the evidence. And now the question to ask is, how well did each theory expect that evidence? It's called the likelihood. And if the evidence is reasonably likely on your theory, then you're doing all right. And if the evidence is unbelievably unlikely on your theory, you're in a bit of trouble. But it's about the comparison between the two. If they're both really unlikely, then actually it sort of evens out. So, if it were the case that the constants, just any old life would work, whatever theism said about it, you wouldn't have this case where naturalism just drops through the floor because it looks really unlikely on naturalism. The probability of a life-emitting universe on naturalism would be like whatever, a half, a tenth, just some order of one number, and the fine-tuning argument wouldn't work. Not because God says this, that, or the other. It just wouldn't matter anymore because naturalism handles the evidence fine. Right? So that's, I think, the situation we would be in.
Yeah, I'm just wondering, because to me it sounds harder to think or even imagine a universe where life is unavoidable. Like, you agree that in this universe, even if all the constants are set right at the Big Bang and everything evolved the way it did, the emergence of life, there's still a chance it doesn't happen. Right? It doesn't have to happen.
From our perspective, in terms of whether it's predictable.
Yeah.
You got to get, there's a God's eye view of things and an us eye view of things.
Yeah.
Right?
So as of now, we have no evidence that it had to emerge based on the laws. It is a possibility.
Sure.
So if a designer had set up a universe where this was something that had to happen, there's no choice in it, wouldn't that have been even a stronger case for a designer as opposed to a weaker case?
We're getting into a bit. If the universe were no, it wouldn't. Not because theism has any sort of troubles with it, but because when you look at the other probability, remember it's all about the comparison, as you know, of course. You'd say, like, what's the probability of life emerging in this universe if naturalism is true? And if that number's about 1, then, I mean, if a likelihood of the evidence is 1 on any theory, then that theory is doing as well as any theory can do. And so the real force of the argument is precisely that once we've set up this sort of case study, it's even if it's the probability of a life-permitting universe on naturalism just drops through the floor, 10 to the minus 100 and whatever, right? Just ridiculously small probabilities come out, depending on how you want to sort of flesh those out. That's the crucial point, right? And there doesn't seem to be, although, you know, if you want to do some theology and go after it, there doesn't seem to be a comparable reason to send the probability on theism through the floor. So
just to summarize, in case this is getting a bit complicated, you're saying we look for the theory that makes the evidence most likely. I mean, maybe if you think about a detective who, you know, the DNA evidence, the murdered person's DNA was all over Luke's body. You know, which theory makes that most...
Kill the Australian, sure.
Most likely? Is it that Luke's the murderer or Martin's the murderer? Which theory? So you're saying we look at this evidence and we take theism and naturalism and say which makes the evidence most likely. Trying to clarify that point. What do you think, Martin?
Yeah. So again, I think that already when formulating the question is highly problematic, as phrased concerning the whole universe, because you make a choice. You make a choice in saying I want these sets of parameters varied, and now even if you assume that there is a way of varying that outside of a multiverse setup, just saying if I were to vary them, if I give them arbitrary values, then what we would get is a life without universe without life. But there's a lot more you could vary. You could change the laws. It's not that complicated. We could imagine a universe that's completely different physical laws. You could even change the mathematics. I mean, you said the fact that 2 + 2 is 4 is more ingrained than whatever name you've been given by your parents in the first place, which to some degree is true, but it's because we're two humans talking, right? If you talk to another life form, or even artificial intelligence, I asked ChatGPT, it gets a lot of math wrong. So if those guys set the rules of math in the future, they might look completely different than what we have at the moment. I think that if you allow for all the possibilities, the idea that it is fine-tuned for a specific purpose is as good as any other question, and the probability measure will always turn out to be very, very tiny. But again, I think we have a reason to ask that question. That reason is because we're asking about us, and there's this inherent motivation of figuring out who we are, what we are, and how we came here, which I'm not saying is bad. I'm not saying it is necessarily something that shouldn't be asked. I'm really interested in how we came here and how it happened. I'm just thinking if this is the baseline of more fundamental question of driving research, it typically in our history has hindered it more than it has progressed the research that we are doing. I'm wondering, I don't want to ask all the questions, but I have many questions to Luke's worldview here. Good. So there is more to that argument than just saying God designed the universe, or a designer designed the universe, or mind designed the universe, and then let it go and everything emerged, right? It's just setting the boundary conditions, or rather the question is, did that entity just set the boundary conditions? So would you say, for example, you could easily imagine a universe where God sets the boundary conditions but get it slightly wrong, so he comes back and the binding energy of helium has to swap, it has to change now like a billion years in, otherwise it doesn't work out. Or I have to change the strength of the weak force because I see these decays, they mess up my plan. I have to change that somehow. Going back or looking at the universe, we don't see any instance of that. Although there are a lot of religions and believers that think there is a time when that entity came back, and that is to rectify some rules that humans have set up, like to save the sinners or to help us to understand our moral values better. So apparently, the idea would be, if we take that seriously, that there has been a designer, a mind that designed the universe, and everything is so perfectly set up that life emerges. So it must be powerful enough to manage that. But then it's not powerful enough to have us figure out morals for ourselves. It has to come back and intervene at that point. Is that not something that concerns you?
Right. So you're in great philosophical company here. Hume talks about this. What if the bungling God who just messed things up 1,000 times, and we're his like millionth, experiment or something like that. I think there's only so much you can get out of thinking about fundamental physics, right? I've never had the guts. I've always wanted to do a lecture on fine tuning and have the last slide just be the directions to the nearest church. I've always wanted to do that, but I never have. Just because, of course, you're not going to get those directions out of fundamental physics. There's only so much that you can do. So these are big questions. But if we're in that realm, right, if you're going to ask, why would God, intervene in this way to bring about moral knowledge in a certain way, then we're talking moral philosophy. And I'm not a moral philosopher. You're not a moral philosopher. I'm not sure. You're a philosopher of mind. Yeah. I mean, is there anyone in the house? What's important about that is once you start asking those bigger questions, a bigger set of evidence comes in. So what I like about fine tuning is it's really a great chance to just bite off a bit. It's the spherical cow again. Just bite off something we can get our teeth around without just trying to think about everything all at once. Beyond that, I'm not saying in any part of this I can in detail predict what God would or wouldn't do. It seems to me that there might be reason for God to directly communicate with us. Or there might not. I mean, if you're thinking about morals, there's this weird middle ground that you'll work out if you haven't already with your kids. Like there's the helicopter parents who are just constantly looking over them, and there's the sort of slacker parents who let their kids do everything. And good parenting is somewhere in the middle. And now we're talking about parenting, right? We're supposed to be talking about physics, but that's the sort of discussion you've now got to have. Like what would a mind behind the universe who we think is good, what approach would they have to and that's just a huge, I mean, I'd love to have that chat, but that's a huge discussion that brings in a lot of other evidence about human nature and morals and evolutionary histories of morals and the actual history of Christianity and other religions and all this sort of stuff. That's a big question. So, from my point of view, in the fine-tuning argument, all of that sort of gets lost in the noise of, sure, if you think it's really unlikely, give the probability of this universe on theism a hit of, 1 in a billion. Like, make the probability a billionth smaller. If the fine-tuning sends the probability on naturalism low enough, that won't matter. It just doesn't. It won't affect the sort of the weighing up we do at the end of the day.
Yeah, I think it looks suspicious, at least to me, that that mind that was responsible for setting the universe up so beautifully let everything run with the push of a button, and it works perfectly well until the point we emerge, and then it comes back and intervenes just to get that right. Like apparently all the complexity of the universe it was able to fix at the very beginning, but then it seems to have something to do with us again. It comes back to help us figure out how we should behave or how we should act between each other. That sounds like a very human-centric point of view, to say the least.
Thank you. God, I'm torn now. I don't know who's right. I do. I have an opinion, but that's not the point.
We're taking a short break there, but we'll be back in just a second for the final part of today's episode, the audience Q&A with today's guests, Martin Bauer and Dr. Luke Barnes.
Pretty much universally, social science suggests that many of the institutions that we hold dear, that shape us, that provide us social support, a huge amount of this used to happen anyway inside of these traditional religious structures, and there really has been nothing to replace it.
It's amazing how quickly ostensible deontologists transform before our very eyes into utilitarians on this question. We're talking about what the self is here. I mean, atheists believe in the self. Everybody believes in the self.
Well, no, that's not. I mean, that I find difficult to believe. Why would an atheist believe in the self? The self is a series of non-deciding mechanisms. The arguments against God are fairly compelling, and I think the arguments against atheism are fairly compelling. The difference is that most people who believe in God have expressed doubts, and a lot of people who are atheists tend to be more religious in this way than many of the people who are God believers.
If people listening agree with me that free will in fact doesn't exist, and simultaneously agree with you that free will is somehow necessary for the upkeep of civilization, then I would simply ask them to consider who's relying on the delusion here. This show does seem to have an extraordinary capacity for putting me face to face with people that I've been talking smack about online, so thanks again.
We're back for the final part of today's podcast episode, and let's dive straight in with the audience's questions.
Right. So our wonderful student assistant Lily here has a microphone. If anyone has some questions.
Just to clarify, as it were, good sorts of human-centric questions and bad sorts of human-centric questions, because it strikes me that all the questions we ask are at least a little bit human-centric, and all science is done by humans, human scientists who have questions that they want answers to for all sorts of reasons, practical reasons, political reasons, ethical reasons, existential reasons, like in this case. But it seemed to me that you can't just complain that this question is set up too human-centric and that's bad for science, because all science is in part human-centric. So just could you clarify, like, the good kind, as it were, and the bad kind?
Well, I'm not saying you're of course right. I mean, everything we do is done by us, so it's trivial. It's not. There's no deep mystery behind this. But not every question we ask, like when we formulate an answer to a question that we ask, I would be suspicious, let's say, if it includes our existence, even if it at the outset wasn't even related to that. It's difficult to phrase that more sharply, I suppose. But let's take an example. There are some parameters that are responsible for whether we are around. These are the parameters that Luke is mostly concerned with, like the up and the down quark mass. There are other quarks that exist that have absolutely nothing to do with the matter we are made of, because they decay immediately. They are there for a blip of a fraction of a second and they are gone. Their masses seem not to be related to the emergence of life. But they have been precisely set in the same, presumably they've been set precisely in the same way. So I can ask these questions, for example, what is the lifetime of a top quark? How does it work? These questions are not necessarily human-centric in that sense, other than that I'm the human asking that question. Someone comes back to me and says, well, that result seems suspicious because my theory assumes that all these quarks should be completely disconnected because they are not responsible for life. That would be an answer that is focused on something that we want to be true, not on the observation itself. I'm sorry if I can't answer it better than that.
Any other questions? All right, lots of questions. So Goff here, and then if people keep their hand up, I will try it. You got a question?
If fine-tuning does point towards God, what kind of God does it point to? I'm thinking of it in very general terms. Is it a traditional theistic God who fine-tunes from the outside, or is it a pantheistic God for whom fine-tuning would be something like self-care?
That's a great summary. I think the argument is mostly agnostic. That's why I phrased it in terms of mind at the bottom, and then there's a load of open options there. Like I said, we're not going to derive the directions to the nearest church. So I think, some people have talked about this in terms of maybe this is an argument that we're in a simulation. The mind upstairs is just a simulator who enjoys making these universes. If you understand that, I think you get the logic of the argument at least. But I don't think we're going to get anything particularly specific beyond sort of, a mind might want to make other minds and find that valuable and be able to do so. And I think that's the sort of bare minimum here. Beyond that, if that's enough, again, as I said, enough to get you interested, there's a bunch of other arguments you can go and have a look at in sort of this space. But there's limits.
There are some strange people out there who thinks this might point to a conscious universe or something very weird like that. Okay, question here?
For Luke, I know you said you wanted to skip it, but you were talking about consciousness. And you said it was the one thing that we can't deny. I just wondered, like, what your definition of consciousness looks like, and just a bit more on that.
So I'm taking Descartes' line here. I think, therefore I am. Whatever else is true, I have to be a thinking kind of thing. Because if I think I'm not a thinking kind of thing, that's me thinking. And what else is true about me? I can leave that open. But that's bedrock. I can't doubt that I think and am a thinking kind of thing. And that'll do. That's sort of enough to get started, I think.
One of your strongest arguments, I think, in your very compelling case, was about probability. That on the naturalist account, the chances of this world existing as it does is infinitesimally small. But I think that falls victim to a fallacy of observational selection, in that we exist in this world. Therefore, we don't have an objective viewpoint, we have a subjective one, and it must exist. To be able to ask the question, why are we here? To be able to posit probability presupposes that we are here. So can you explain to me how your argument about probability is relevant?
That was very precise. That was excellent.
Thank you. That's outstanding. So this is called the anthropic principle objection. Part of me sort of attacks this. Within astronomy, selection effects are just sort of our bread and butter. You've got to deal with those every day. What a selection effect is there's a population, but you don't see the whole population. You just see a sample that you drew from the population. If you want to make an inference about the population, you better understand how that selection happened. So selection effects only really work if there's a population. So I think my view on this, and I think the view of most, certainly physicists who talk about fine-tuning, is the selection effect can't do anything unless there's a population for it to work on. So that will work great if there's a multiverse. Then you get the two sort of probabilities. What's the probability that a life-emitting universe is somewhere? Handle that. And then what's the probability that we observe a life-emitting universe? Well, then the selection effect kicks in. There's no one around, getting upset at all these terrible universes. So I think that's where it comes in. But you need the multiverse. And then you've got to, if you're trying to weigh these things up, you've got to weigh up all these sort of, I think, pretty thorny questions about multiverses. Some of them are scientific, some of them aren't. And I think in the context of this, the question is, what would I expect to happen to this question of, what would I expect if somehow I could convince myself that naturalism would lead me to expect a multiverse, just purely, not scientifically, just pure naturalism. And that's, I think, a very hard question to get a handle on. Yeah.
Question over here?
This is for Luke. I think Martin talked about this point a little bit earlier. I guess my question would be, do you think that these sort of random and probabilistic effects like spontaneous decay or quantum tunneling happening early in the universe would have a large effect on what happens later in the universe? And if so, how could a God know that we would be created? Or how could we be created in God's image or be similar to God in that we have like a purpose or we want to do something? I just think that, I just can't see how God could know that we would be created.
Great question. It's a very good argument. If you want to push that really hard, a defense of that exact argument's by Alex Rosenberg called Theism and Allism. That's about the best. Anyway, just to prop up that side first before I have a go at it. I think you've got to keep in mind there's a difference between probabilities can depend on what you know. So the unpredictability of certain physical systems, either in practice, chaos, or in principle, if quantum mechanics is indeterministic, and that's an if, that's a sort of us level perspective. We're inside the system, which makes cosmology a really weird thing to try and study. You're studying the thing you're in. God would have an outside view on this. And again, as a simulator, there's how I do it. I'm not saying that's how God would do it. But if I ran a simulation where every time a sort of random event happened, I just chose the next digit of pi, or the next couple of digits to work it out, what would happen next, then the universe would be completely unpredictable from the inside, but completely predictable from the outside. Because the digits of pi behave as random numbers, but I know exactly what they are, right? And so unless someone on the inside works out the pattern, which if they're sort of scattered around the universe would never happen, then those two things can sit together. So this is the sort of argument where I'm not pretending to know what God would do, but is this sort of thing possible where it would look random but actually be sort of laid out in detail, where the average properties would go this way but specific things would go in a way God could predict? It could happen. That's all I'm saying. It's possible.
Was there a question at the back? Question at the back here?
Hiya. Yeah, I just wanted to ask that all the arguments that look to include God have God defined as an all-knowing, all-powerful being, as in that there would be intent, rather than that there could be accidental creation, like if I sneezed on the window and it was in the sun, and all that bacteria is questioning why it's special and it must be intentional. Do all the arguments have God as this humanoid? Or could it just be that something created life, and that would explain why there's this big gap, and that there's no one's coming back, because why would I even be aware of what was in the sneeze on the window? I've created life into the things in that sneeze. I am the creator, but doesn't give me any more credit than that.
So again, I don't think we're going to get a complete picture of God out of this, but for the fact that if you say, you know, those constants initially are just whatever they are, they could have been different, they just picked some at random, then a life-emitting universe turns out to be unbelievably unlikely, which is a reason to think of some other hypothesis, right? And the sort of thing that comes to mind as those quotes from Freeman Dyson and Fred Hoyle things, the thing that immediately pops to mind is a mind, conveniently, right? Just foresight, it just fits, right? There's plenty of other questions to ask, but at least that, you know, it's not a completely unknown thing. We are that sort of thing. So, yeah, that makes it sort of us-centric, but that's the question we want to know about.
We're honoured to have in the audience Tim Mulgan, who has defended on similar grounds ananthropic purposivism, that there is some creator or purpose, but it's nothing to do with us. We're a sort of accidental byproduct. So try to account both for fine-tuning and maybe some of the problems traditional theism has with suffering. So I just thought I'd throw that in. But we have a question from Mark at the front here.
If we assume for the sake of argument that it's a meaningful question or a meaningful problem, the fine-tuning problem, what do both of you think about whether that could itself be evidence for a multiverse?
So I don't think that fine-tuning is a good argument. But many of my colleagues wouldn't say that, I think. But I don't think fine-tuning is a good argument for the multiverse alone. I think it calms the nerves of many that this would be a possible explanation. But the multiverse, especially a multiverse that addresses fine-tuning, is a very specific scenario which assumes that we have a cosmic inflationary mechanism that isn't directly evidenced yet. Like there's a lot of hints at that. And that string theory is true in a specific way as well. That gives you a constellation in which the multiverse, in that there's a mechanism where additional multiverses are produced, and that laws might be different. But in most of these setups, that is not even a given. It's not even clear that the laws might be different. It's just that this is the direction, I think, from which the idea comes that we should look at varying constants in the first place. Because in string theoretical frameworks, the constants that set, for example, the strength of forces are set by geometry, by the way the extra dimensions compactify. There are different ways of this can happen, there are different ways of folding a paper, basically, and all end up with different laws, if you will. So this is where the motivation comes from. If you would ask a string theorist that works on multiverse or that has this as a consequence of their theory, they would set apart certain things. They would, for example, not say that gravity is something that can change. Like every universe that exists has to have a version of general relativity because that is equivalent to space-time. There's no way to not have that. If you don't have a multiverse, if you think about designer, I don't see why this would be a constraint. Why not just think up whatever you want? Like again, this parameter space is infinite dimensional. So if you ask whether the fine-tuning argument, you say whether it motivates the multiverse, right? I think only in a very, very specific framework. I think it's often overemphasized how much physics, even in terms of the multiverse, even addresses that question yet, because we don't know whether these theories that predict the multiverse are actually true.
Do you know what's something, Luke? Because, I mean, many physicists, such as your co-author Geraint, would say, yeah, this really needs explaining, but we don't need God. We just do it with a multiverse. If you've got enough universes, with different numbers, one of them's going to get the right numbers for life. What's wrong with that explanation?
I don't think there's anything wrong with that explanation. In terms of, I'm not going to, tell the universe, or God, or whoever, right, how the universe is. We've got to go find that out. So if that's a way of getting universes, again, you get those two things. The right numbers will turn up somewhere, and we'll be in one of the universes that got the right numbers. And it seems like, given the shape of the constants we're talking about, that does some explanation for you. In terms of the question of, so that's, let's do some science. In terms of this deeper question of matter at the bottom versus mind at the bottom, actually, that's exactly the point I was going to make. Is it only very specific multiverses that give you the right constant somewhere? Or does any old multiverse do it? And we're sort of asking that same question again. Is this any old universe, or is there something rare going on around here? Just drops down a level. Is this any old multiverse, or is there something rare going on with this multiverse? My problem with the multiverse at the moment, we have no clue how to answer that question. But, as I said, whatever physics does tomorrow, we'll reevaluate the argument. So we'll keep doing physics.
Okay, we have another physics professor here. Tom with a question.
I'm a scientist, as you say, but I'm not so keen on this fine-tuning argument, partly because if there is a great designer, they or she has gone very wrong with Donald Trump being elected president, I say. But so I would prefer to argue that you shouldn't believe scientists, right? I'm a scientist, and I'm saying you shouldn't believe them. Because take it from me, so far less fine-tuning, if you ask a scientist to explain the existence of that chair that Martin is sitting on, the existence of it, from first principles, would you have any idea how to do that?
It would be difficult to do.
And so you could take it two ways, this. You could end up arguing for Martin on this argument. But the way I'm taking it is, if scientists can't even explain that bloody chair he's sitting on, then you can't really rely on us to make decisions about religion and God. The only second thing I would say is that the biologist's fallacy, right, which is that, if you come along and say, there must be a God, because if I go out in the morning and feel the sun on my face, feel wonderful and say, everything's so wonderful, there must be a God, I'll have 5,000 biologists coming towards me saying, but you've been selected. If you are sensitive to UV radiation, etc., the sun, then you'd be dead and you wouldn't be around to tell us this, this nice feeling you're having. But that misses the point. The point is, why is there that nice feeling of existence in the first place, right? Why are you allowed to exist with that nice feeling? And that's the question, not the particular circumstances of any, particular statement that's made, in detail. So that was all I wanted to say, and I shall thank you very much for letting me say it. Thank you.
Either of you want to add any thoughts on that?
I interpreted it going slightly in the direction of I was arguing that a complex system like the universe, asking for the fine-tuning of this system, encompassing all possible things that could go different, is to me not a well-phrased question. And then as soon as you constrain it to a certain set of parameters, for example, to explain like the last step in the production of that chair, you can say more and you can talk about probabilities and likelihood, but you're biasing the question because of the initial step there. So I think, I think that I agree to the point that if we go to more complex system, arguing from first principle becomes more and more complicated and impossible at some point.
Okay, maybe we can fit in a couple more questions. So Chris Oldfield there had a question.
Hi, thanks very much, both of you. Luke, this may be one for the pub, so feel free to just say, no, we'll shift that. But you tantalisingly laid out 6 options, matter, mind and maths.
Yeah.
And you mentioned Max Tegmark. And I was just thinking on the best of a bad bunch problem with inference to the best explanation. If you're comparing naturalism and theism, and let's just grant you're right on that. Do I take it from what you're saying that if you had a kind of Max Tegmark view where the physical world is somehow a structure of, well, I don't exactly understand his view, but could you just speak to, if you played it on the other game, theism versus mathematical necessity, Would you try to run this argument at all, or I just would? It's a kind of fishing rod to hear what you'd say.
Okay, so what Max, I think, would say is something along the lines of, what if mathematical consistency and physical existence just were the same thing? If that's true, then he calls this the level 4 multiverse, right? The ultimate of multiverses, like every mathematically consistent way of anything exists. And now we've got to think about that idea. And good luck, everybody. Maybe 4 beers in, maybe 5. The thing I'd say is there's way more ways for the universe to be. So think about the mass of the electron as a function of time, just purely abstractly, mathematically. There's one function where it's constant. And there's loads of functions where it goes all over the place. And there's loads of functions where it's constant until 3 seconds from now and then goes all over the place. That didn't happen. I think if that view of the universe is right, it would predict a universe which is completely chaotic and bananas, because he can't privilege simplicity, right? There's that principle's not in there. And so a universe which has any form of simplicity, like the mass of the electrons the same yesterday as today, is just ridiculously unlikely or completely impossible to think about. So I think he's bitten off way more than he can chew in that one. That would be my... I'm not sure it's the same argument. I think it's... I think all arguments are really Bayesian arguments, but that's another story.
Should we just have a question from the man in the green jumper? If you just...
So I just wanted to go back a bit to when you were talking about probabilities and like Bayesian probabilities and how unlikely it would be for life to emerge in a naturalistic universe. I feel like maybe it's not completely justified you saying that there's a way things could have been, or to make assumptions about the probabilities of the constants being as they are, when in reality... Like maybe you're making an assumption there that probabilities are inherently a part of the universe, but in reality, probabilities are a way of humans predicting the future. In the past, the probabilities have already collapsed in maybe this is sort of a frequentialist line of reasoning, but it's like they've already collapsed. There's an 100% chance that life emerged because life did emerge. And you can't really go back and say there's a chance things could have been another way, because you don't have any experience of things being another way or any knowledge that it could have been.
Yeah, so absolutely none of this works on a frequentist understanding of probabilities. If all you're doing is counting actual examples, then the probabilities go like this. 1 universe, 1 life-permitting universe, 1 out of 1. Nailed it, right? But that's not what we do with probabilities when we try and test theories in physics. So I would say to flesh this, if I had time to flesh this out, we're trying to model our own uncertainty. I think that's what Bayesianism does. We're modeling the epistemic, the situation we're in regards to evidence, and just trying to do the best we can to take account of, trying to answer a big question like what sort of universe would you expect if naturalism were true, and then to boil that down to, okay, what would you expect if, of all amongst the constants, because that's a bit we can get a handle on. We're just trying to model like uncertainties in that sort of sense. It's a way of being systematic about, thinking. That's what I think Bayesianism is.
But does that not need to be justified more in the past, to assume
I've got plenty of uncertainty. No, I don't think it needs to be justified in the past. I think it needs to be justified by the sort of theoretical and, mathematical foundations of Bayesianism. So you look at things like Cox's theorem. You look at, the work of Edwin James, and the sort of people who said, look, what would it look like if, there was a way to put a number on plausibilities and if they obeyed certain desiderata? And I think you sort of build it from that way, the bottom up.
I'd like to thank both speakers for incredible contributions, wonderful discussion, and all of you for stimulating them and pushing them further with your questions. So let's give one final applause for everyone. Thank you very much.
That brings us to the end of today's debate on the question, is the universe fine-tuned for life? I hope you found it interesting and enjoyable. If you're listening on Apple Podcasts, please do consider giving us a follow. And of course, if you're interested in hearing and exploring our other debates, podcasts, and articles, you can find those on our website. Thanks so much for joining us today. Until next week, from me and the team, goodbye.